Ladies and gentlemen, hello everybody. Are you ready for a reactive journey for this session? Cool. So, at first, let me introduce myself. I'm Igor. Probably from my horrible English, you already guessed I'm local. I'm from Kyiv, work at Cyclum, and working on the Zoom Data project. It's our staff project for American company. And I like it because we do a lot of stuff with databases. So we query databases to create visualizations. So let me show you, something like that. And also we use Spring Boot and Spring Framework stuff, as well as a lot of reactive programming. Are you hearing me well? Because it's really hard to speak with such a huge place. So. We are actually using a lot of stuff that we're going to do to talk today, a lot of database work, a lot of reactive programming, and also we are hiring now. So if you are interested in a new cool project, please catch me somewhere after this talk and have a conversation. So also I'm a co-author of this book. It's a bit dated already. It's 1 year old, and for reactive programming is already a lot of time. But if you are new and want to start, it's probably not the best, but a reasonably good thing to start. So what we are talking today? We are talking about why do we really need reactive database access at all? Because probably nobody required it, and it wasn't a thing even 2 years ago. Why do we need it at all? But we already have R2DBC, and we'll look how it is consists of, and we'll try even to build a toy driver with it. I assume that you know a little bit, at least, what is reactive programming is. Who is completely new to reactive programming? Okay, I see a couple of hands. So guys, you will either understand nothing about this talk or be very optimistic about that, or both, what could be cool also. So let's start. Why do we really need reactive database access at all? Because reactive programming gives us the following thing. Usually it's non-blocking. Yeah, so who work with reactive programming needs to know that the main stuff is not block threads. To be efficient, not block threads, it means non-blocking, at least in Java world. Usually it's asynchronous, so it's something like callbacks, but a little bit more complicated. So we do not get result immediately, but we are notified when the result is ready. It's declarative. It's like Stream API when we do all that fancy map, flat map, filters, all that things, and do not iterate manually. Also cool. It's about processing streams of data. So it could be used for getting a piece of data, but it really shines when you have a stream of data, like WebSocket messages or stream of prices somewhere on the stock market. And recently, it became even resilient. So reactive programming gives you all the mechanism to build a resilient application without need of other libraries. It supports back pressure, because nowadays, reactive programming without back pressure, it's not reactive programming. Who knows? Who do not know what is back pressure is? So, okay, a couple of hands. So, back pressure is the ability of the subscriber, the one who's consuming stream of data, to say that, okay, guy, I'm overwhelmed, do not send me data anymore, or send me just a couple of pieces of data, not the whole data set you have. Because if I'm a mobile application, I won't consume a gigabytes of data that server may easily send to me. So we have to somehow control this stream of data. It's about back pressure. And the cool thing that Reactive Stream standard that was released a couple years ago describes as a document how all these things should work together. So it's like a set of rules that allows us to reason about reactive application, reactive programming, and know that everything works well, at least in theory. So, and all this about high efficiency. So we want to use reactive programming not because it's new and fancy, but because it allows us to decrease the amount of servers we need to deploy our application on. So if you say have 10 servers and paying 10 grands of bucks per month for that, and now if it's just 2 times more efficient, you will have to pay half the price. So that's why it's really shining now when we have a lot of SaaS applications, deployment to the cloud, and we're starting thousands of servers. And then we again cool when we may reduce that resources we use for application. And as Mark Pollock recently tweeted, kind of cool place to cite people, reactive programming is the next step in evolution of how do we develop applications. First it was imperative, then non-blocking using callbacks. It's pretty old technique. Then message-driven, that was on the rise even a couple years ago, and now reactive programming is kind of the top hype thing, at least for now. So also, Spring is Spring Framework. Who uses Spring Framework? Everybody uses Spring Framework. It's reactive now. So guys who develop it decided at one point that reactive programming is not just a hype. It's a cool thing that is good enough for be a default, well, not a default, but one of the main programming technique to implement your applications. And now Spring Core has dependency on the project reactor, and starting from Spring 5, you may write reactive programming with your beloved Spring. Cool. Spring is based on the Netty. Netty is a networking library that is pretty cool but hard to use manually. That's why Spring brings us WebFlux, web clients that are wrapping the Netty calls to bring us reactive programming. And also Spring has Spring Cloud, Spring Messaging, and other models that are reactive now. Okay, but we are talking about database access. What do we have, what Spring offers us for database access? So we have Mongo, Cassandra, Couchbase, Elasticsearch, Redis Neo4j, it's in beta now. And Elasticsearch was just released a couple of weeks ago. So we have pretty considerable list of databases and even new arrivals recently. But you will ask, what about SQL? Because none of that is not a Postgres, MySQL, Oracle, or whatever database you use. And usually you will answer GDBC. So yeah, databases uses, so we in Java usually use GDBC to access databases. So let's look at GDBC from the standpoint of reactive programming. So let's bring that list of requirements. Backpressure and reactive stream standards, it's not applicable at all. But GDBC, it's blocking. So it's not non-blocking. We cannot easily interrupt with it. It's completely synchronous. You cannot set a callback. You just block and return the result. It's not declarative. It's imperative. You should to call whatever you want, and you cannot write GDBC flat map, unfortunately. It's not about processing streams. You may only ask for data and return it all, and you cannot subscribe to stream of events, let's say. And of course, it's not resilient, so if you get some exception, you have to handle it and do it on your own. And the worst thing for reactive programming is GDBC blocks threads. So you always have to have a thread that will be blocked when you're waiting for data from your database. And if your database is fast, let's say sub-millisecond response, it's kind of okay. But if you do analytical queries or you have big database and most of the time you're spending on the database, you have a lot of threads in Java applications that are blocked, that do nothing, cost money, cost memory, cost CPU cycles, but do nothing. And it's not efficient, that it's not sufficient for reactive programming. However, I would say that GDBC is kind of cool thing because it's pretty old. So it was released in 1997. I probably was like this that time. And to compare what happened in that year, it's Titanic movie was released. So it's really, really old one. And it's still alive, we still use it. So kind of cool artifact, but probably we may move further. And that's why we're talking today about reactive relational database connectivity, R2DBC. Like RR is better R2 than RR. So R2DBC is a new thing that if you want to look at it, it's R2DBC EOS site that holds a lot of information about it. It's sponsored by Pivotal. It's not the first thing that tried to tackle this problem GDBC. There was a couple of other tries before, but I think it's most promising now. And it has a couple of principles, like it's based on reactive streams and reactive types. It's completely non-blocking up to the database, so nothing should be blocked in any place where you're running your application. It tries to utilize wire protocol, the protocol you communicate with database, for non-blocking communication, because usually you communicate through the network, and network itself is non-blocking. It's just GDBC blocking that tries to wrap that non-blocking complexity. And it divides client API and driver SPI. We will talk about it later. And try to shrink driver SPI. So it has only two dependencies, reactive streams and Java 8. And reactive streams is a small jar file with 4 classes and only 1 kilobytes. And also that reactive stream specifications that classes were adopted by Java 9. So when baseline of the R2DBC will move, let's say, to Java 11, it won't have any dependencies at all. So it would be kind of cool, small interface library. And it consists of these layers. So we have SPI in the middle, client API on the top, and drivers at the bottom. Something kind of a bit different than GDBC, but let's look at SPI. What is SPI? At first, the most important is specification. It's a document that says how your driver should behave, how it should communicate with database, and what to return to the client. And in contrast with GDBC API, it's not for human and drivers. It's only for drivers. So it's for those who write drivers. That's why it's small. That's why it does not have all that stuff that is concerned of the client application. And that's why it should be easier to write drivers with it. So it consists of these classes, nothing special. Connection factory, connection, statement, results, raw metadata, and raw. If you look at GDBC, you will see the same stuff. It's obvious. And kind of this is how we get statement from connection, result from a statement. And because it's reactive programming, we have back pressure propagation through this chain. What's kind of cool. SPI, let's look at connection. So it consists of a couple of simple things like create statement, easy. Then we may manage transactions like begin, commit, rollback, save points, all this stuff. And then close it, easy. Statement, we may create statement, bind some prepared parameters, let's say, execute it, and get a result. Result, either we update something and we get number of rows that was affected by that update, or trying to map the stream of results from the database with this cool map function. And row allows you to get the column by the identifier or by name. Pretty simple, yep? So, how it looks like when you're using it. Let's say we have H2 connection factory, and this is what you need to create it. Of course, if you will have Postgres, you would have password, user password, host port, all that connection config you need. And from that connection factory, we may create connection. And because it's reactor-based, we'll create mono. That mono we have to flat map, but to flux. That's why we use flat map many. And then create statement, like select currency price from trades, and then flat map result. But you see, I've asked for currency and price, but here, from flat map, I'm getting only currency. So even though database returned me 2 columns, here I will here I will kind of get only currency and transform from the bytes only thing that I really need. The price won't be marshaled at all. We can do something like batch insert, and you see we use these symbols to represent what we want to bind later on and execute. Transaction. It's because SQL and relational algebra allows us to do transactions. Why we use Postgres instead of Mongo. Okay, Mongo has transactions now, but not Cassandra, because it has transactions. It's a really cool concept, and R2DBC has to support it. This is what we need to begin transaction. So you say connection, begin transaction. And this is what we need to do commit or rollback. So it's something like try with resources, and you see that it's not very easy to write. Kind of, yeah? You may forget to do something of this, usually. However, it's SPI. It's for drivers. It's not for us to use. So it's very, very short introduction to what SPI is. Pretty simple. Let's go higher at the level of that we usually use, at the client API. Some library that allows us to interact with it without a lot of boilerplate. So we have a client that may wrap our connection factory. Yep. Now, from that client, we may call different method, call this handle, and do a statement. But now you see, we have kind of named parameters instead of unnamed. And this is a thing that R2DBC client adds to R2DBC itself. Then we may bind them by a name. Okay, let's look what should we do for transactions. Only this one. So we say statement in transaction, and that in transaction will do for us all that hassle that we was seeing before. So the main aim of the client to make our life easier when interacting with the R2DBC. And R2DBC client is not the only one client. There could be a couple of them. And because drivers implement only SPI, we may have alternative things, whatever library we like, you just interact with SPI directly. And we are not bound to this one. Cool thing, we may do stream processing. So let's say I have a Postgres, just ordinary Postgres, and I create this statement. Listen user login notification. User login notification is a channel somewhere in Postgres. Who have ever looked at listen command of the Postgres? A couple of hands. So Postgres is not the only database anymore. Kind of all databases is not only databases anymore. Postgres has ability to send notification to clients. Let's say we have a channel where we put notification like a trigger when session was created to table. We trigger notification to the channel, this channel, that something happened. And on other application instance or somewhere else in application, I may just say, I want to listen for that event. Postgres, as soon as you receive this, please call me. And it would be impossible to do with GDBC. And with R2DBC, it's easy. We just say connection, get notification, unmarshal notification object, and subscribe to do something useful with it. And it's reactive stream. It's just streaming from the Postgres itself. So it's kind of cool. Let's look at the databases and what we have there, what support level we have. What R2DBC was started, kind of released a year ago. It's all in development now, but we have H2 for testing, kind of cool. We have Postgres, pretty cool database. Who uses Postgres? A lot of you. Cool. We have MySQL, even two of them. They are not as good as for Postgres, but it's also very popular database. And Microsoft SQL Server. And it's cool because actually reactive programming, as we know it, was born at Microsoft tens of years ago, and now they are also, okay, not they, but SQL Server is supported by it. Recently, guys from SAP said that they have driver for SAP HANA. Who knows what a SAP HANA is? Okay, nobody knows, don't care. It's in-memory database. It costs a lot, probably more than Oracle. And what is that? Google Cloud Spanner. It's another transactional database from Google. It also has reactive driver. However, because we have support for Postgres, these databases also are supported, like CockroachDB. Have you heard about it? See a couple of hands. Yep, it's SaaS database, or like a cloud database. And even though it's different database written in different language, it supports Postgres protocol. So it says for driver, I'm Cockroach, but you may call me Postgres, and I will return your results. The same for MySQL. Something like MariaDB or MySQL are based on that protocol. So all these kind of supported now. So let's look what we have from the coverage standpoint. So this is what we have from the reactive non-SQL databases, and this is what we have from the R2DBC. It's kind of most popular databases that are in use, was in use a year ago. And yeah, it's not 100%, but it's pretty good for most of the use cases. So also, R2DBC has good support in Spring, obviously, because it's pivotal. And from the Spring Boot, we have all the goodies that we need, like tests, actuator integration, auto discovery of the drivers, and so on. Spring Data R2DBC, it's another module from the Spring Data to bring us what we love from Spring Data, but it's reactive. So we may write repositories with R2DBC. But now we have to extend R2DBC repository instead of CRUD repository and return not the sales data DTO, but flux of sales or mono of sales of reactive types. Cool. What's about transaction? So it was a trouble for R2DBC for some time, but now you may write something like that. Just add transactional, and everything that is inside will be run under the one transaction. It's cool. It has some limitations, like you cannot mix reactive project reactor with React Java, because the whole idea of transactions implementation in Spring is based on the reactive context. So, but it's reasonable limitation. Also, do not do this stuff, because will take 10 elements and then unsubscribe from the transactional context, and will kill transaction, and it's what you do not want. But probably that's all the limitation we currently have. Okay, let's look how R2DBC driver works inside. So, because we want to go deeper, let's say we have Postgres database and our application that have R2DBC Postgres driver. Easy, yep. How they should communicate? Through network, yeah. How this communication is called, do you know? Have you heard word wire protocol? So this is the specification of what driver and database interchange between each other. It's wire protocol, and in case of Postgres, it's TCP based. So actually we're sending bytes, like query with length and string with some representation of the query. Select one, let's say. And Postgres will send us data row or chunk of data rows with these bytes, D, int, all that stuff. It's kind of C-like because Postgres itself is pretty old, but we may write a wrapper that just parse it. And this is how it looks like from the standpoint of message exchange. As you can see, it's really reactive. It's exchange of messages. We send the query and get row descriptor, the types of columns we will have, and then data row, data row, data row, and then complete and ready for a query. One limitation that Postgres connection may do only one query at the time per physical connection. However, it's still pretty reactive. The driver itself looks like the following. We have a client, it's where we're sitting, this Postgres connection itself, and important stuff. We use netty, not we, but driver uses reactive netty client. It's a wrapper of the netty library to send bytes, receive bytes from the database itself. So kind of we send messages and receive messages. This guy handles all that's required for network. Here, we then marshal messages from byte buffers that is not very useful for us to something like statements and result set and all that we need from on the upper level. And you will ask, where is back pressure? Because it's important for Reactive. Yep. And in case of the Postgres, there is a cool stuff called portal. It's internal to the protocol itself in database, but I may send a query and ask to do something like select users with some criteria, and then ask only for certain amount of data rows I'm ready to receive. Let's say 2. And then send another 4. And only then database will send me that message. So even though this stuff was invented when nobody knows what is reactive programming is and what is back pressure is, it's something like late 80s, it still supports reactive programming back pressure concept. Cool? Cool. So, but of course, we engineers, we should know what's bad about it, because it's cool and shiny, but cannot be everything cool and shiny. Who of you use GPA? A lot. I have a bad news for you. No Hibernate, no Eclipse Link, and no GPA so far. The trouble is that GPA is heavily based on GDBC, and it's also blocking, and it doesn't support callbacks, and it's heavily bounded to the thread local state, which cannot be used in reactive programming. So far, it's not there. So you cannot use GPA, but you can use still repositories that if you do not need all that fancy stuff of GPA, Spring Data may bring at least most of good things. However, recently was introduced Hibernate RX. It's a sub-project to try how reactive programming and R2DBC would affect GPA or Hibernate itself. So probably we may get it in a year, 2 or 5, something like that. Also, longer queries. So usually, databases are trying to return results as fast as possible, because kind of we send the query, it's begun some locking stuff inside the database, calculated the result, and streaming out results. And now, because of big pressure, we may say, no, give me one row. OK, I'll wait. One again. And now, database has to hold all the data somewhere. And it's kind of OK if it's buffer, but it's horribly if it was some transaction open at that point. Also, from the transactional standpoint, because of that big pressure, we may create more contention, because previously, queries were fast. We begin transaction, execute, close it. OK, we could do something wrong with that previously also, but now it's easier, because we have a back pressure. Back pressure will just begin transaction, we just do something, and we will asynchronously close that transaction later on. And now transaction is longer, have more contentions, and not all databases like that transactional contentions. So it may decrease the performance. So kind of GDBC may be even fast, in some cases, even faster than R2DBC. Faster doesn't mean better. R2DBC is aimed to scale better, to give you better through output, even though latency could be slightly bigger. And of course, if your database is kind of OK with what R2DBC is asking from it. Because as you can understand, last 20 years, databases were tailored for JDBC workloads. And they have a lot of tricks to work well with JDBC. And we need some time so they could handle R2DBC patterns well as well. And also, kind of because of that, R2DBC has to impact the protocol that communicates and the database internals itself. Also, it may kind of affect protocol because it's not about sending big chunks of data. It's about streaming small pieces with big pressure. Also, it's good if database support cancellation, because it's very often that we subscribe to something and then cancel something. And if database is doing a lot of wasteful work at the same point, it's not good. And it's kind of cool if the protocol itself, like, for example, Postgres, supports reactive stream semantic. OK, one more thing. Postgres has only one query per connection. But if it's completely asynchronous, we could potentially use one connection to set hundreds of queries with some correlation ID and then get results without opening the whole lot of connections. So no connection pools. Could be cool, could be easier to manage. And there are protocols that support that, like RSocket. It's completely reactive, but as far as I know, no database at the moment uses it. But probably in future. So what else do we have there? We have something like R2DBC proxy. If you want to log requests, if you want to some augment them, add some auditing, there is a special module to allow you to do it easily. Also, we have a R2DBC pool. So, for example, for Postgres, we still need pooling, and this small module could provide a reactive connection object pool. It's pretty simple set of classes, but it's handy that it's there. Okay. What is the future for R2DBC? It's still in release candidate, but authors say that they want to release the GA, something like release version, to the end of this year. And it's still not it's not the first version, would be the first version, but it should be pretty good for usage. And next is something like better transaction support, event providers, not just from the Postgres connection, but as a part of the specification itself, and stored procedures. It seems that a lot of applications use stored procedures, and we haven't seen anything about stored procedures in API yet, but it will come. And more improvements for the libraries that work with databases. OK, let's try to do some demo. We are going to compare now how JDBC is better or worse with R2DBC. So we will have your devices connecting to the application that is using Spring Data, R2DBC and JDBC to communicate with Postgres. So let's try to go here. You have mobile applications, you have internet, so you should see some map of US. Yep. Is it working at all? OK, I see. OK, I'll wait another 10 seconds to give you a chance to go there. I hope the server will survive this. So let me look what's going on there. I'm opening it on my machine. As you can see, we have ability to query data, some sales data, let's say, by some region. It's artificial pretty, but as you can see, when using JDBC, I'm using JDBC now, we have thread pool that has to run the JDBC, and I said that only 8 threads, and it's not enough for all of us. That's why we have a lot of requests that are queued, so it's horrible. Kind of all of you who are on JDBC now are waiting for resources so your query may be processed. However, on the R2DBC side, because it's non-blocking. We do not wait on a database. We just send request and say, okay, database, as soon as you get result, return it me. It should be served there. And as you can see, there are no queued results. So even though I have only 4 threads for R2DBC, it processes all the requests in parallel. Probably somewhere Postgres is dying because it's now serving 70 requests at the moment. However, if it would be something like CouchDB, SaaS solution, it won't be even my problem. It would be a problem of the provider. I'm just paying money for good database. And now I'm not limited by the GDBC itself. I may use R2DBC and win a little bit more there. Cool? So let's go on. We haven't write that driver itself. We just use Postgres. Let's try to write a small one. It shouldn't be hard. Presto. Who of you have heard about Presto previously? Presto database? No hands. Okay, so it's a kind of solution that was created by Facebook, and later on Teradata put a lot of effort in it. It's for querying big data. HDFS, S3, so a lot of data you have, you may query with it. It's a query engine. It's like a database that you may only query and cannot insert data directly. You have to do something like bulk upload or map files to query it. Also, Amazon has Amazon Athena. Have heard about it? Somebody? Couple of hands. It's the same Presto, but just rebranded. So Amazon just resold the Presto like a service. And a lot of companies use this, of course. And there are even 2 of them now. And both of them, they say that they are official Presto. So it's funny story. A year ago, the guys from Facebook decided to make a Presto foundation, created a fork, and now we have 2 forked versions of a Presto that have different code paths and different development roadmaps. So, yeah. However, they are pretty similar, so let's say it's one thing. So we may have something like S3 storage or some R2DBC storages like Postgres, and let's say Mongo. And some of the data is in Mongo, some of our data in Presto, in some in S3. And we cannot, let's say, do a join with all of them because they are in different databases. And Presto allows to do it and in distributed mode. So we may kind of register that database tables in Presto and join data from the S3, Postgres, and Mongo. So something like magic, but it actually works. And usually it's used for analytics, so a lot of analytical tools. And this is official from the kind of Presto database site. And as you can see, Zoom Data, project I work on, is also listed there. It's kind of one of the cool UIs that could work over the Presto. This is the architectural diagram of the Presto. And we are here, we are client, sending the request to coordinator. And what's cool, results are not returned from the node, the application we send requests to. Result is returned from some other worker somewhere in network, so that even the queries that may run for long or may take a lot of cluster resources may process. That's why we won't kill the coordinator itself. It's a pattern that I do not see very often in databases, because when you usually send requests, you receive the response from the same machine. This will affect our architecture, because we have to send the request to one node and receive data from the another. And it uses HTTP. It's not TCP based, and it's not some cool binary protocol, it's HTTP. So let's write a driver for it and kind of put in that row also. How it will look like from the implementation standpoint. We have Presto, our driver, we have via protocol, and obviously it's HTTP instead of TCP. Then we send in SQL query, and results are returned JSON. So it's also kind of not something that we usually do with databases, but it's protocol of the Presto, and it's cool because it's easier for us to parse JSON than parse bytes. Yep. What do we need for implementation? Of course, Java, SPI, because we have to be compliant to the R2DBC. We will take Project Reactive library for all that reactive stuff. And also for ease, I will use Java 11 HTTP client. That client is Reactive itself. It's new client, cool client in Java 11 that supports reactive semantics. Usually, libraries using something like Reactor 90, but it would be OK for us. We will do JSON parsing, so we add some libs for that. And of course, we need Presto instance. So let's get hands dirty. OK. At first, I have a Presto instance somewhere here. It's running in Docker on my local machine, because that's why I coordinate on the worker on the same machine, but it could be distributed over the network. And I have one active worker, no running queries. And the last thing, I'm doing something like select 7. Let's make a query, first query, and it's not reactive, it's from Postman, but I'll just send the statement to this URI. We have one statement. Let's calculate something like 7 over 8. I don't remember what it will be. Let's Presto say us what it will be. And also I need to authenticate. I will say that my user is root. It's in the headers of HTTP request. Nothing special. Let's send it. Bombs. I've sent it. Let's go to the Presto. Nothing. Still nothing. It said that my request is queued. It's not executing now. I have to go to the next URI to get it. And it probably be a worker, not the coordinator. And send again. And it says, queues again. Try again later. Again. Sending a request. Still queued. It's really long query. OK, yeah, you see. 7 over 8 is already in Presto. And it took us about 5 or 10 seconds to get the result. And let's look, 56. Do you remember 7 over 8 is 56? So Presto is right, yeah? But you see what we have to do. We send a request, we send a query, and then waiting when Presto will calculate it. We have to go to the next URI, next, and all the time it's the new instance of that URI. And when the result is there, we will get it. So let's try to write it in code. So I won't write codes. I'm horrible at speed writing. But I have a couple of commits to show you what we need. So first of all, we have a baseline, a couple of classes that is required for R2DBC. Let's say connection. OK, let's try. Do you see what's there, or it should be better? It should be bigger. So it Presto connection, nothing special. We implement connection from R2DBC and return nulls or throw exception, nothing special there. And this is just an empty implementation of the classes we wanted before. Let's add some DTOs to it, like when connecting to the database, we want to know what the version is that. And also we validate that the cluster is alive. And it's just some DTO, JSON DTO that will be modded here. Something like version and uptime information. Cool. We will write a small JSON parser that we just unmarshal JSON to the class. You may do with different libraries. I'm using something like Devoxx JSON, but it doesn't matter. And statement response. You remember that next URI. This is what we should go when nothing is present, and we know whether it's present or not with the status. This would be queued or kind of data ready. We have also, when we have data, we will see columns. That's something like person name, something like salary, all that stuff, and the list of objects of data. Simple. Also add some utility to kind of compile that URI we need to do. Nothing special in this commit. Then let's add the connection. So connection factory is pretty simple. Let's even check out this revision. So we have a connection. As you can see, that connection just wraps the HTTP client and something for JSON parsing, and also we have already connection, the connection information like user that we need to put in that header that is sending, and nothing else here. So kind of pretty useless, but we added the metadata. For connection factory at this point just creates new client, so cool, Java 11, we're using vars, cool stuff, less code. Build client, create JSON parser, and send a request. You see client, send async, request, info request, and as soon as it returns, return the database info object as a mono. Cool, nothing special, and it's already non-blocking. Let's go further. So the next thing from the connection, we want to have ability to execute statements. So we have a connection. Now we may say select 7 over 8. For that we have a statement. Statement on its own just inherits the HTTP client, because statement has to do a lot of requests. I mean, it requires client. The same JSON parser, and also SQL that we want to send it, because it's connection, execute, and that is SQL that we have to execute. This is a little bit of magic here, but we have to send the SQL statement, create a request, nothing special, just HTTP request with headers like user, catalog, schema, and username. And we then do client send async. So we just send in a request here. And as soon as result is coming, we're trying to unmarshal statement response. So this is what we will get. Statement response. It would be first time, it would be queued. So the query was queued. And then we have to retry. And Reactor has this fancy thing called retry that we may do unless we get the actual response going to the URI get next. So actual next and doing retrying. Nothing special here. So final thing that we have to do as soon as we check out. So the last thing we have to do is when we get actual result, just parse it and represent as R2DBC result, R2DBC row metadata. And in statement, we only kind of create from the statement JSON, response JSON, actual result that is required by R2DBC. So let's check out this version. And also I have some tests here. A simple test that will do something like this query. Okay, make it bigger. And with our Presto connection factory, it's our own implementation. We will try to query localhost and 8081 with user root, this catalog, this schema, and make that query. And as soon as result is arrive, I'll just print it to the console. Easy? Let's run it. I have to compile it, and idea is not very fast at that, but we are running. So let's look at log. Starting, as you can see, we already have to fetch version. So this is Presto version 3 1, 2, something like that. It's our connection validation. So we get information from Presto. Then we send in request to the statement and get in response, kind of queued, then executing, and then response data arrives. And we may log it, something like day 1, November, Kyiv, Devoxx Ukraine. Cool. Let's try a different query, and also let's look that it was logged. So yeah, you see we've sent the actual query. We may do even something like what other queries I have? Some more complex query that it's not only works for hello world, it works for something like select with joins, with a lot of where clauses. So we've changed it to this query and run it again. It probably will take a little bit longer, but hopefully we will see the result as well. Send this query and waiting. And UI should say that we are running this query. We've sent actual query from that test to the Presto cluster, and it's currently running. It's bigger query. It's not something like 7/8, but probably it should also not take too long. So it's running, and it's finished. And now we get result here, data row, some data arrived. Cool? So in general, in total, we had to implement only this much of classes, and most of them are empty implementation. Of course, it's not production ready, but it's thing that I've done in a couple of hours when I was riding from Kyiv to Odessa on the upper shelf in train. So it should be good enough for a first iteration. So let's go to the presentation again. So, of course, our implementation is not as good as we would like it to be, but we've spent only 5 minutes here and a couple of hours in the train. So it's not so bad. And the main thing that it proves that it's possible and it's easy, even without some fancy stuff like netty to use to build the drivers itself. So, what can we say else? It's cool, it's new and shiny, and it actually brings reactive access. We have never blocked the thread while doing Presto communication over our client or communicating with Postgres through the R2DBC Postgres driver. Has active community and kind of a lot of interest. As you can see, it's not so hard to implement drivers, especially when they are using HTTP as a protocol and JSON when returning data, not the raw bytes. But also, it has some not cool things, like it's not GA. It's not probably ready for production just now. No GPA, of course. We do not know how reactive programming will fit SQL stuff at all. It's just a new thing that arrived a year ago, and we need a couple of years of practice to know whether it's a good idea or whether it's better to return to GDBC world, and who knows. And also, they say that reactive programming is gonna die because of fibers and coroutines that are going to arrive in Java soon. Something like Project Loom. Who of you heard about it? So probably some other speakers will talk about it today or tomorrow. But it's something like C# async await and Kotlin's green threads at the same time. So it's logical threads that do not require the same amount of memory as the physical threads currently in Java. And with that, we may write blocking, synchronous code, do not care about functional programming, or just write imperative code, and use old GDBC and GPA. However, this is what brings reactive programming. And kind of fibers and coroutines removes non-blocking and asynchronous communication and declarative saying that, no, this is new fancy stuff, but let's try to do it in the old way. However, it cannot cover the stream processing. And Kotlin also added another library or feature of the library itself, coroutine flows, to handle these cases, because Coroutines itself cannot handle reactive streams of data. Resilience, it's not present anywhere, and it's something that reactive programming gives you, and for Coroutines you need to use some external libraries. Back pressure, you may simulate, it's a good idea in general, and it won't appear from Coroutines itself. And reactive stream standards gives us a very cool thing, that the application logic that you write with reactive streams in Java, JavaScript, C++, or other language, when you're using reactive programming techniques, is the same. Because async-awaited coroutines differs from the language to language. It's more than one language. It's cross-language concept. So that's why I think it's not all doomed. So, summary. We will have reactive access soon. Spring Data is driving R2DBC, so it won't be forgotten. So Spring Data is pushing it. Also, it's time to try, probably not in production yet, but if you try today or tomorrow, in a half a year, it might be kind of driving your application somewhere in production. And we don't know how reactive programming and fibers from the project Loom will coexist, or whether fibers will kill reactive programming or enhance it, but it's interesting thing to look at. And thank you.